spacecraft, you can see at the bottom here there's a pendulum. In this configuration, the pendulum is well below the center of gravity of the rest of the frame. The frame is made out of wood, and it's slightly a little bit heavier than your pendulum, so the center of gravity would be above that pivot point. And this is the configuration that CD says is unstable and Bongui says is stable. And I will be holding it at the bottom on either side, so it will be able to rotate about an axis that is in the plane of the screen right now. So it'll only be able to rotate about one axis, which is equivalent to the models that both CD and Bongui use. So I'm going to hold it with my fingers right here and allow it to rotate about this point, which is analogous to thrust vector control design, where you have a articulatable main engine, which is what the Bongui design has, and it's effectively analogous to what the CD model is, which is a thruster control design. So when I let go and let it rotate, I'll have to turn it this way so you can see the pendulum, but you'll see that the slosh mode, the pendulum, will get excited fairly quickly. And I have to hold on to it to keep it from just falling out. See how big that is? It just goes crazy. This is the configuration that Marcel CD says is the stable configuration, and Bongui says is the unstable configuration, where the pendulum hinge point, which is at the very top of the frame, is above the center of gravity. Okay, here we have the configuration of the pendulum hinge point being above the center of gravity. I'm going to let go. When I let go, the frame will rotate about my fingertips here, which is equivalent to the thrust vector control design of a main engine being located here and just pivoting about the axis where my fingertips are. And well, here we go. Let go. You can see that the pendulum mode is not getting excited, at least not to the extent that it did in the other mode, with the other configuration where the hinge point was below the center of gravity.